Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths Practice Questions on Misleading Graphs. If you need any extra help in Misleading Graphs, if you go to Corbettmaths and go to the Videos and Worksheets section and scroll down to video number 160A, there's a dedicated video tutorial there on Misleading Graphs. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. So question number 1 says, Miss Kennedy surveyed a group of students on what day they wanted a new club to take place, and the table shows the results. So 6 students voted for Monday, 5 students voted for Tuesday, 7 students voted for Wednesday, 2 students voted for Thursday, and 1 student voted for Friday. And Miss Kennedy drew this bar chart to show the preferred day. So she's drawn this bar chart to represent the data in the table. And then if we read on, we've been asked to write down 2 things that are wrong with the bar chart. So we want to write down 2 things that are wrong with this bar chart. Now, whenever I'm doing questions like this, the first thing I do is I look at the bar chart and just see if there's anything obvious that jumps out at me. And I can see here, if we look at the bars for Monday, Tuesday, Wednesday and Friday, they've all got the same width. They're all one big box across, or 5 of the little boxes. So 1, 2, 3, 4, 5 little boxes there, or one bigger box across, and that's Monday. And Tuesday's got the same width. And for Wednesday's got the same width, and Friday's got the same width. But if we have a look at this bar for Thursday, this bar is wider than the other bars. It's actually got a width of 1, 2, 3, 4, 5, 6, 7 little boxes. So it's wider than the other ones. So that I wouldn't do that. Whenever I was drawing a bar chart, I wouldn't have one bar that's wider than the others. So let's write that down. Okay, so that's mistake 1. The bar for Thursday is wider than the other bars. Let's have a look at mistake 2. So let's see if we can find another mistake. So in terms of the bars, well, we've got Monday, Tuesday, Wednesday, Thursday and Friday. Fantastic. Let's check the height of the bars. So we've got 6 for Monday. Yep. 5 for Tuesday. Yep. 7 for Wednesday. Yep. We've got a height of 2 for Thursday and a height of 1 for Friday. So the heights of the bars look okay. But let's have a look at this vertical scale. It goes 0, 1, 2, 4, 5, 6, 7, 8. The number 3 has been left out here. That shouldn't be 4 there. That should actually be 3. So it should be 3 and then 4, 5, 6 and 7. So actually that vertical scale is wrong. The number 3 has been left out. So let's explain that. And that's it. I've just written down the vertical scale leaves out the number 3. It's left out the number 3. And it goes 0, 1, 2, and then 4, and not 3. And that's it. So that's the 2 mistakes that I've written down for this bar chart. The bar for Thursday is wider than the other bars, and the vertical scale has left out the number 3. Okay, let's look at our next question, question number 2. So question number 2 says, the bar chart shows information about the number of Year 12 students late on a Monday. So it shows the number of Year 12 students that are late on a Monday. So let's have a look at this bar chart. So we've got these different classes. We've got Class A, and it's got the number of Year 12 students that are late from Class A on a Monday. And for Class B, we've got the number of students late for Class B, and I'm guessing this would be Class C. And then if we carry on, it says make 2 criticisms of the bar chart. So criticism, we were trying to write down things that are wrong with this bar chart. So whenever we've been asked to write down 2 criticisms of a bar chart, we're trying to find 2 things that are wrong with the bar chart. So let's go up and have a look at the bar chart. So we want to find 2 things that are wrong with it. The first thing I notice is actually this bar hasn't been labelled. There should be a label here. Is it Class C? Is there a Class C? Perhaps it goes Class A, Class B, and then Class W. I'm not sure, but there should be a label for this bar. So that's the first thing. Let's write that down. So I've just written down the third class has got no label. And then in terms of the second criticism, let's have a look at this and see if we can find a second criticism here. So in terms of the vertical scale, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that looks fine. They're all going up in the right order. And then we've got here the bars. They've all got the same width. They're all 2 boxes across, 2 boxes across, 2 boxes across. So that all looks fine. Okay, so let's look a bit further. The bar chart has got a title. The vertical scale's been labelled. Actually, here, let's have a look at this. Class A. In Class A, there's 1, 2, 3, 4, 5, 6 students that are late. But if we have a look here at Class B, we've got here that there's 1, 2, 3, 4, 5, 6, 7, 8, and then it's in between 8 and 9, so that would be perhaps 8.5. You can't actually have 8.5 students late, because the bar chart's meant to show information about the number of Year 12 students late on a Monday, and Class B can't have 8.5 students late. So let's write that down. And that's it. I've just written down that Class B says that 8.5 students were late, and that's not possible. So that's our 2 criticisms of that bar chart, that the third bar wasn't labelled, and that the height of Class B implies or says that 8.5 students were late, and that's not possible. Okay, let's look at our next question, question number 3. So question number 3 says, Alexandra records the number of cars in a car park over 3 days. So on Friday, there's 60 cars in the car park. On Saturday, there's 57 cars, and on Sunday, there's 54 cars. And she's used this information to draw a bar chart. So we've got this bar chart, and then the question says, write down 2 mistakes that she's made. So she's made 2 mistakes while drawing this bar chart. Okay, so let's have a look at this bar chart and see if anything jumps out at us. So the first thing I notice here is the number of cars with this vertical scale. It's going 48, 50, 52 and so on. And that implies there's actually quite a big difference between the Friday and the Saturday and the Sunday, because it starts at 48. If the bar was actually to start at 0, you'd actually find that the bars would actually be a bit closer together in terms of the height. So the vertical scale here should really start at 0. It shouldn't start here at 48. So let's explain that. Okay, so I've just explained that the vertical scale starts at 48, and that can sometimes imply that there's bigger differences between the bars than really the case. You'll see later on there's another question where it's a bit misleading and it's intentionally done that way, so this sort of is to imply that one of the bars is much lower than the other ones. So whenever you draw on bar charts, you'd want that vertical scale to start at 0. Now sometimes for other types of charts, you might want to actually start at 48, so perhaps if it's a scatter graph, sometimes you'll see a little zigzag there to say that some numbers have been skipped out, but for this bar chart you wouldn't want to start the vertical scale at 48. Okay, and then in terms of the second mistake, so let's have a look at this. We've got Friday, Saturday and Sunday. They're labelled, that's great. The bars have got the same widths, which is fantastic as well. Let's look at the height of the bars. So Friday, 60. And then, so if we go up, Friday, was it 60? Yep. Saturday, it's then got a height of 58. There's 58 there in terms of the height. And if we go up to the table, we can actually see it's meant to be 57 and not 58. And Sunday is 54, which is meant to be. So that one's right and that one's right, but that one's wrong. It should actually be 57. So let's explain that. And that's it. I've just explained that the height of the bar for Saturday is incorrect. It should be 57 and not 58. Okay, let's look at our next question, question number 4. So question number 4 says, Emily owns a catering van. So she owns a catering van, and the table shows her total sales of tea, coffee and hot chocolate last month. So she sold £500 worth of tea, £790 worth of coffee and £350 worth of hot chocolate. And Emily drew this bar chart to represent the information in the table. So this is the bar chart she's drawn. And we've been asked to write down 2 criticisms of the bar chart. So we've been asked to write down 2 things that are wrong with this bar chart. Okay, so let's have a look at it. So the bars have got the same widths, fantastic. The vertical scale starts at 0, great. The horizontal scale has been labelled tea, coffee and hot chocolate, that's good. Okay, let's then have a look at them in terms of the height. So we've got tea, 500. So let's see, was tea £500? Yep, that's right. Coffee, £790. So let's have a look at the height of the bar for coffee. It should be 790. So here, let's write down what number this is. So we've got 700 and 800 in 1, 2, 3, 4, 5 little boxes. They're not going up in tens because that would be 710, 720, 730, 740, 750. It must be 20s. 700. 720, 740, 760, 780, 800. So that's £780 in terms of the height of that bar, and that's for coffee. But if we look at the table, it was meant to be 790, not 780. What she's probably done is gone to 800 and just gone down one box, assuming that's £10, but it's actually £20 she's gone down by because each of the little boxes is £20. That's £780. So that's one mistake. Let's explain that. Okay, so that's the first criticism. The coffee should have a height of £790, but the bar only goes to £780. Let's check hot chocolate. So there, that's 300, 400. It's in the middle, so that's £350. And yep, that's right as well. Okay, so now one thing I notice here is the vertical scale. It goes from 0 up to 900, but it doesn't actually say what it is. So this is the total sales. So total sales, and it's in pounds. So there should be some sort of label on that vertical axis. So let's write that down. So the second criticism that I've written down is the vertical axis has no label. There's no label there for that vertical axis. It should be labelled as total sales or something like that. Okay, and that's it. Okay, let's look at our next question, question number 5. So question number 5 says the table shows the number of goals Jack, Tolga and Neil scored last season and this season. So last season Jack scored 14 goals and this season he scored 13 goals. Tolga last season scored 10 goals and this season scored 16 goals. And Neil last season scored 12 goals and this season scored 14 goals. And then we're told the coach drew this dual bar chart to show the information. And then we've been asked to write down one thing that's wrong with the dual bar chart. So we just need to write down this time one thing that's wrong with that dual bar chart. Okay, so let's have a look at it. So we've got Jack, Tolga and Neil. Yeah, that's good. We've got a key, so last season and this season. So last season, this season, last season, this season, last season, this season. Great. Goals scored, going up vertically, so it starts at 0, fantastic. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, yep. Okay, so everyone's looking good so far. I hate it whenever you're doing these questions, you can't see the mistakes straight away. Okay, so let's have a look at the data. So Jack last season scored 14 goals, yep, so that's right. This season scored 13, yep. Tolga last season scored 10 goals. That's not right. That should be 10. And then this season 16. So those two bars actually should be the other way around. So he's actually drawn those two bars the other way around. It should be that he scored 10 goals last season and 16 goals this season. And then finally Neil, 12 and 14. So they're correct. So the mistake that the coach has made is that he's done the bars for Tolga the wrong way around. He's done 16 and then 10, but it should be 10 and then 16. So let's explain that. And that's it. I've just explained that the height for Tolga's bars are the wrong way around. And that's it. Okay, let's look at our next question, question number 6. Okay, so question number 6, we're told that the people living in a street were asked if they wanted new street lights. And they could answer yes, no, or unsure. So we've got yes, no, and unsure. And this is a 3D pie chart. And we're told the pie chart shows the results. As you can see, we've got the results here, yes, no, and unsure. And we've been asked to explain why this diagram is misleading. So 3D pie charts are often misleading because whenever you look at them, the sectors at the front, so yes, will seem more prominent than those at the back. So they're quite misleading because the ones at the front will appear they're closer, so they're often bigger. The things further away will be at the back and then they'll appear smaller as well. So 3D pie charts are misleading and I would tend not to use them. I would actually just use a normal two-dimensional pie chart, a normal circular pie chart. Okay, so we've been asked to explain why the diagram is misleading. So as you can see here, it's a 3D pie chart. The sector for yes is at the front. It seems more prominent than the others. I mean, it is bigger than the other ones, but because at the front it seems even larger. So the fact that it's a 3D pie chart is a problem. So let's explain that. And that's how I've just explained that 3D pie charts can be misleading as the sectors at the back, so here in the case of no, the sectors at the back seem less prominent than those at the front. And that's it. So that's what I've explained. I think on the website, whenever I've done the answers, I've explained it the other way around. I've said that 3D pie charts can be misleading as the sectors at the front seem more prominent than those at the back. Okay, let's look at our next question. So question number 7. Question number 7 says, a head teacher asked 300 students in her school how they travelled to school. And here are the results. So 50 students travelled by bus, 70 students travelled by car, and 180 students walked. And if we add those numbers together, we do get 300. So that's fantastic. And then we're told this pie chart was drawn for the information. So this pie chart's been drawn for the information. I'm laughing because this one's been labelled a walk, but you can clearly see that these two sectors haven't been labelled. So that's going to be one of the criticisms straight away, because as we go down, we've been asked to write 2 criticisms of this pie chart. So criticism 1, the sectors for bus and car haven't been labelled. So let's explain that. Okay, so that's the first criticism, that the sectors for bus and car haven't been labelled. Okay, the second criticism. Now if we have a look here at walk, that's half of the pie chart. But if we go up, there was 180 students that walked out of the 300. Now, if walk was actually half, if the half of the students walked to school, that would have to be 150 students, not 180, because obviously 150 is half of 300. So that would be for 150 students. So this angle doesn't seem big enough. If there was 180 students that walked to school, what we would do is we would take 360. We would divide that by how many students there are, which is 300. So let's do that. 360 divided by 300. That's a calculator question. And that's equal to 1.2. So each student is worth 1.2 degrees. So if you multiply 180 by 1.2, that'll tell us what size the angle should be. And if you do 180 multiplied by 1.2, that's equal to 216 degrees. So the sector for walk should actually be a 216 degree angle, not a 180 degree angle. So that angle is wrong. So let's explain that. And that's how I've just explained that the angle for walk is incorrect. It should be 216 degrees, not 180 degrees. Actually, I probably would have got the mark actually just explaining that the angle for walk is incorrect, because if it was 180 degrees, that would only be 150 people, so it should be bigger than 180 degrees. So if you explain that the angle should be bigger than 180 degrees, then that'll be fine as well. And that's it. You could have also looked at the size of the angle for bus and car, so you could have looked at these two, but because they're not labelled, we're assuming that the head teacher meant that this one was for bus and this one was for car. But I probably would have just stuck with walk there and looked at the fact that that angle was wrong. And that's it. So the 2 reasons that I've given for this question were the sectors for bus and car car have not been labelled, and the angle for walk is clearly incorrect because it should be 216 degrees, not 180 degrees, or even just it should be bigger than 180 degrees because more than half of the students walked. Okay, let's look at our next question, question number 8. So question number 8 says, there's an upcoming election in an area. So there's going to be an election in this particular area, and we're told that Harry received a leaflet in the post that had this message. So he's received this leaflet, and this happens before elections. You quite often get these leaflets in your post box, and it says, vote for the Indigo Party. We're the only party that can beat the Purple Party. And then there's this bar chart. So this bar chart's been put on the leaflet, and it says last election results, and there's 3 parties: the Purple Party, the Indigo Party, and the Cyan Party, and we've got the number of votes. And the Indigo Party have said they're the only party that can beat the Purple Party. They're saying the Cyan Party is so far away they're never going to beat the Purple Party, but we can, so vote for us if you don't like the Purple Party. So that's what it says, and we've been asked to explain why the leaflet is misleading. So if you look at this, for our first impressions, if you look at these bars, well, you can see this bar is really close to this bar. These bars are quite close together, but the Cyan bar is so low, it's so far away, it's never going to catch the Purple Party. But actually, if we have a look at the vertical scale, and let's write down the number of votes each of the parties received. We've got 4,800, so 4,800 people voted for the Purple Party. The Indigo Party, it's in between 4,600 and 4,800, so that's 4,700. And then the Cyan Party, if you actually have a look at this, it's actually between 4,000 and 4,200, that's 4,100. So that's only 600 votes away from the Indigo Party, and only actually 700 votes away from the Purple Party. So this bar chart's misleading. It's probably actually intentionally misleading, where this vertical scale has been used on purpose to make it seem that the Cyan Party is so low that you should vote for the Indigo Party instead of the Cyan Party if you want to beat the Purple Party. So actually, this bar chart is actually quite bad form. It shouldn't actually be used, because if you were actually to do a proper bar chart and start at 0, these bars would actually be quite close together, and you could see, well, actually I could vote for the Cyan Party if I actually like them and I want them to beat the Purple Party. So let's write that down. And that's it. And I've just explained that the vertical scale starts at 4,000, and that implies that the Cyan Party received few votes. However, they only received 700 less votes than the Purple Party. So this bar chart is actually quite bad, actually, in terms of intentionally, perhaps, trying to imply that the Cyan Party received very few votes, but actually they're only 700 away from the Purple Party. To actually fix it, this bar chart should start at 0, and then you'd actually see that the bars are much closer together, and then actually you should vote for whoever you want to vote for. Okay, let's have a look at our last question, question number 9. So question number 9 says, the scatter graph shows information about the salaries received by 7 employees and how long they've been employed by a company. And a line of best fit has been drawn on the scatter graph. So we've got the scatter graph, it's got a line of best fit. Let's actually have a look, going up vertically. It's got the salary starting at 40,000 and going up to 47,000. And across horizontally, we've got the years employed going from 0 across to 6. And we've got 7 employees. Let's just check that. 1, 2, 3, 4, 5, 6, 7. And we've got a line of best fit. Now straight away I'm looking at this line of best fit and thinking it's not a great line of best fit because it's gone through that point and that point. But actually we've got all these points clustered beneath that line of best fit. I think the line of best fit is too steep. It perhaps should go across this way, perhaps something like that instead. So yeah, and then if we carry on, actually just one thing to mention is, remember it's a scatter graph, so the fact that it starts at 40,000 is fine, because whenever you're doing scatter graphs you're more looking for the trends, whether the points are going up or down and so on. Sometimes this is a zigzag, in this case it's not, but that's fine. And then if we carry on, we're told the owner of the company claims that the scatter graph shows that the salaries of the employees increase by £1,000 each year they are employed. Do you agree? Explain your answer. So let's have a look here. So if we have a look at the line of best fit, well, if we start at 0, so the employees just started with the company, and this is saying, if we look at the line of best fit, it's saying their salary should be £40,000. If we go across 1 year and up to the line of best fit, we get to 41,000. Across 1 year, up another 1,000 to get to 42,000. Across 1 year, up another 1,000. Across one, up another 1,000. So the line of best fit does imply that. The line of best fit does imply that if this line of best fit was correct, that every single year that they're employed, the salary goes up by £1,000. And it works for this employee in this one. However, if we look at all of these employees down here, they're all below the line. So they're not actually getting as much money as they would be getting if they were on this line of best fit. So that line of best fit is too steep. The line of best fit should actually go up this way and actually be a lot less steep. So let's explain that. So I've just written, no, I don't agree. The line of best fit is too steep, and that 5 employees are significantly below it. We've got these 5 employees that are significantly below that line of best fit. So maybe the owner of the company is manipulating the data to suit them and to back up what they're claiming. And that's it. So that's it. So these have been the video solutions to the Corbettmaths Practice Questions on misleading graphs. If you need any extra help on misleading graphs, I've made a video tutorial on it. And to get to it, if you go to the Corbettmaths website and go to the videos and worksheet section and scroll down to video number 160A, there's a dedicated video tutorial there on misleading graphs. Alternatively, you could scan this QR code. But in this video, we focused on the video solutions to the practice questions. I really hope you found this video useful. And if you have found it useful, please like it and please subscribe to my YouTube channel. Also, if you know anyone who might find Corbettmaths useful, please recommend it to them as well. So if you've got a friend who struggles with their maths, please recommend Corbettmaths to them as well. And that's it. Thank you. Cheers. Bye.